Welcome back, Physics 30. So we'll look at inclines now. So we looked at this question here involving moving along a horizontal surface. Now we'll look at what happens with inclines. So an object sliding down an incline has three forces acting on it. It'll have a normal force, gravity, and friction force. The normal force, key thing to note, is always perpendicular to the surface. Now, usually we talk about it in terms of being equal and opposite to FG, unless we're pulling something at an angle, but it's a little bit different with an inclined surface. Well, really it's not, because it's defined as being usually what we talk about. So if we have our box, whatever, FG is pulling downwards, Fn is pushing upwards. So really it's always the force right here, perpendicular. If this is the surface, perpendicular to the surface is the normal force. Okay? Now if we're talking about, let me see, I'll do this in pencil maybe. If I redraw that, so again we have a box like this, we have Fg, we have Fn. Okay, now if we tilt this, let's make this bigger, let's make it like that. If I tilt it now, Fn is still perpendicular to the surface. Fg is changed now though, especially if I leave it like this, pointing straight down on your screen there. This again is straight down, and this time Fn. So Fn doesn't change. It's always perpendicular to the surface. Okay, that's a key thing to note. So the force is parallel to the is parallel to the inclined surface. The friction force is parallel to the inclined surface, and the gravitational force is straight down. So if I'm assuming that I'm going to be moving this way, right? Friction is always parallel to the surface. So here's the surface, here's friction, it's parallel, even if I rotate it like this, whereas Fg is going to change depending upon how much I turn this by. If the object is at rest, the forces are the same, except that we use the static frictional force, and the sum of forces is 0. Okay, so if we apply that information to a scenario now, we could have something like this. So notice it was horizontal, okay, but now it's tilted. So Fn is still perpendicular to the surface. Fr is working, or friction is working against me, and then you have this pulling downwards. I'm just going to redraw this a little bit. Let's draw it like this. Let's draw it. So we have this. We have Fn. Okay, I'll maybe go back to pen here. I don't need to use pencil. So Fn, we have F working against us, or friction. And then we have this, which we could refer to this as being the applied force. Now something interesting happens here. We have Fg pulling downwards. Now, the geometry of an inclined scenario is like this. This triangle, of course, can be broken down into a right triangle. It's kind of different from the right triangles we're used to, though. Usually we try to make the components on the x and y axis. But if I don't, if I make this, okay, perpendicular to the surface, and then join it up here, I could call this, common practice is usually call this perpendicular, F perpendicular, and over here we have F parallel. So of course we know from earlier math classes that that's the sign for perpendicular, that's the sign for parallel. So parallel to the surface is this, perpendicular to the surface is that one. And then if we notice something, F perpendicular is going to be equal to Fn, the normal force. And F parallel is equal to the applied force, that component that's going to cause a force in the down the slide direction. So that is a key thing to note. And on your reference sheet, I will have that for you. That's the geometry that we're going to be looking at here. So if I can figure out the components of this, once I know what FG is, I'll in effect know what Fn is, and I'll know what Fa is. All right? So if I look at this question, a 65 kg skier has begun a descent on a 30-degree slope. Now, one last piece of geometry. Whatever angle this slope is going to be equivalent to this. And you can see that if I was to draw a series of diagrams in which I started turning this slightly, it would be equal to that angle there. So these are equivalent. All right. If the coefficient of kinetic friction is 0.100, so that's mu k, assuming it's moving, what is the acceleration? So like previous examples, we're going to have to figure out all the forces involved, and then from there we'll be able to figure out the acceleration. So first of all, Fg is likely the easiest one. Fg is equal to mass times gravity. 65 kg skier multiplied by negative 9.8. It's going to give us negative 637.0 newtons. Okay, so we know what Fg is. Now, if we know what Fg is, we'll be able to figure out what F parallel is and F perpendicular. And then we'll know these ones. Everything will come out in the open then. So let's figure out F perpendicular and F parallel. Now, for the sake of this simply means a direction. When we're talking about F perpendicular, F parallel, man, it's kind of hard to tell. Is that going to be negative, positive? So we'll just leave the directions off for now, which means just disregard this negative for now. So F perpendicular. So this is the opposite side, hypotenuse, adjacent. So adjacent, that means we're using cosine. So the cos of now that angle of the inclined plane, which is equal to this angle here, 30.0 degrees, equals adjacent side over hypotenuse. So again, not including that negative sign. So 637.0 multiplied by the cos of 30. Of course, make sure your calculator's in degree mode. That's going to give us 551.658 newtons. We'll just leave those digits there for now. And of course, that is also equal to Fn. So Fn is equal to F perpendicular. So it is 551 as well. All right. Parallel. F parallel here uses the opposite side, so we're using the sine function. All right. So F parallel is equal to 637 multiplied by sine of 30. So F parallel, 318.5. And parallel, also parallel is FA. So FA is equal to F parallel, so that's equal to 318.5. So with just figuring out that triangle, we figured out 4 forces because of this relationship and the geometry that exists with an inclined plane. Okay, so let's see, we know this, we know this, we know this. We know FA, we know Fn. That just leaves friction here. And we know what, we can figure out friction because we know what Fn is. Because the force of friction is equal to mu multiplied by Fn. So how we define friction there. So Ff, now the coefficient of friction we're told is 0.1. So that's going to give us 55.1658 newtons. So we know what that force is as well. Okay. Now, in terms of, we know that this block isn't going to levitate upwards or downwards. So it's like what we've done before. So if I was to rotate this, of course, the horizontal motion is what we're looking at. Now, of course, the horizontal motion has been tweaked a little bit. It's kind of angled downwards. So instead of calling it horizontally, I'll maybe put down the plane as a direction that we're going to be looking at. So the net force down the plane, we have FA and we have FF. And as we can see, we are going to get a value here because FA, which is equal to F parallel, 318.5. And I know it's down the plane, but we'll assume it's just like horizontally, we're going to the right, that's positive. So I know it's kind of awkward because we're saying down the plane is positive. And friction, hey, as long as it's the opposite value to this, we're doing it right. Negative 55.1658. So again, I figure out the magnitude of friction, now figure out friction in the scenario. It's always opposite. So F net is going to be equal to 263.3342. And here I can likely round it off. See, I'm using previously calculated answers, so I didn't round it off just yet. 263 newtons. And I'll just simply say down the plane to do away with the awkward positive sign dealing with downwards. So net force, it's experiencing a force of 263 newtons down the plane. And of course we're asked to find the acceleration originally. So of course once we know the net force involved, we can figure out. Now here I'm going to use the previously rounded answer. 263.3342 is equal to the 65 kg mass divided by 65 divided by 6. Hopefully you didn't run out of room here, ladies and gentlemen. A is equal to 4.05129 meters per second squared. I think we can round that off to 3 sig figs. 4.05 meters per second squared. And the same direction as F net down the plane. Okay? So that's how we handle the inclined plane. The key thing there is remembering how that geometry works here. And I'll have it on your reference sheet, so I'll have this part here. I think I even have this part here. So you just have to be able to know to work it. And you can see how making that right triangle, we can figure out all of these forces involved. All right, we'll see you again.